We only have 2 sections left. I'll warn you now, we're going to start with section 9.3, and by itself, 9.3 is not a hard section. When you mix it up with everything else we've been doing, it's hard to distinguish between 9.3 and 9.2, which was what we did when we had 2 means. So I'll talk about it as we go through it today, the differences between what we're doing today compared to what we did last time. But you want to make sure you're really thinking about how is this different than, say, that quiz problem I just did. Because when you're in the exam next week, they're all mixed together and you have to be able to distinguish between them. So I am starting on page 134. Page 134, section 9.3. And if you look at the title of it, it says, Test and confidence intervals when comparing dependent samples. Last time we did independent samples, where maybe you were comparing men's heights to women's heights, or maybe you were comparing, I don't remember what it was. We had the students from 93 compared to the students, current students. This case, you don't actually have 2 samples. Well, you actually take that back. You have 2 lists of numbers, but they're from the same sample. For example, let's say I gave you the chapter 8 and 9 test on day 1. You guys probably wouldn't do so well then. And then I give it to you again next week. And for each one of you, I have your score from earlier and your score from later. So I have 2 lists of numbers, all the early scores and all the later scores, but they're actually matched up in that I can take Phoebe's score from before and Phoebe's score from later and see how she did. And then I can do the same thing with Kaya. How'd she do early and how'd she do later on? So those are actually, may sound like 2 samples, but it's really only 1 sample of people with 2 numbers from each. That's what we mean by a dependent sample. So if you're looking up at the top, there's a little paragraph that describes some of this. We call that matched pairs, where you have pairs of data that are actually matched up. Maybe it's one person matched up to another person later on. Maybe it's brothers and sisters, like we got all these siblings and we ask the brothers questions and the sisters questions and they're matched up in some way. The most important thing is to look at your data and decide if they're matched up or not. So there's a list up there of all the different things you might think of that makes it matched pairs. The reason we care about it is it looks like 2 samples, but it's really only 1, so we have to approach it that way. So I'm going to start by looking down at example 1A. They're looking at the BMI of college students, and they measured each student in September and April of the freshman year. So September is when they went into college, when they started college, and April is when they finished the year. And there's a claim that we're going to test in a minute, but just look at the data. And looking at that data, how many students did they look at? 5, she says? We agree there's 5 students? Only 5 students. There are 10 numbers here, but the first line there, where it's in the 20.15 and the 20.68, the first column, those are from the same student. It kind of helps to think of it as like you're labeling the student. Student number 1, that's a number, sorry. Number 1, number 2, number 3, going across the top of your data. So you actually have, this student had 20.15 in April and 20.68 in September. I'm not going to write the rest of them down because you have it. But these numbers went with the first student, and then these numbers went with the next student, and so forth. So I actually like to suggest putting numbers across the top so you can see that you have a sample of 5 people, and you know which ones are matched up with the others. So when we call them matched pairs, this right here is a pair that goes with this person. Right? And then over here you've got a pair of numbers that goes with this person, and so forth. So we don't really have like a sample from April and a different sample from September. Everyone okay what I mean there? The last section you could have had that. You could have said, hey, I measured some students in April, then I measured some other students in September, and you could have had 2 separate lists. So it's important to read that they came from the same people. So these are actually matched pairs. When you have matched pairs, we're not interested in looking at the 2 lists. We're looking to see if there was any change from, in this case, April to September. Did people's BMIs go up? Did they go down? What happened for individual people? Was there any difference from one to the other? So we actually have to create a 3rd list down here of the differences. Because that's really the goal. Is there a difference? Differences, if you could spell. Difference is, my E's and my C's all run together. Differences. We want to make a list of all the differences. What happened to this student? What happened to that student? And so forth. So if I just want to do the differences, I just want to take this number minus that number. You guys have your calculators handy? Negative what? 0.53? Let's just stop and pause and make sure we understand what that represents. Do we agree with him? The subtraction? I didn't. What does it mean to be negative? For this person, this is the person's BMI when they started college. This is the person's BMI when they finished their freshman year.
They lost weight?
Yeah, it looks like they lost weight, right? It went down. Their BMI went down. Do you agree with that? Because this is the beginning. It's hard because it's upside down. This is the beginning of the year. This is the end of the year. School starts in September, ends in April, right? So this person, their BMI went down over the course of their freshman year, which makes sense that the difference would be negative. And I don't have the rest of the numbers here. Someone want to tell me what the differences are? I can hear you guys calculating them.
Negative 0.24.
Negative 0.24. Keep going.
1.18.
Positive?
Yeah.
I need
Negative 0.72.
and
0.36.
0.36. Positive? So are there any questions on where those numbers are coming from? A shorthand suggestion on how to get those so you don't have to do 5 or more subtraction problems. Here's my shorthand suggestion. Put this list in L1. Put this list in L2. You don't want to do it now necessarily because you already did all the subtractions. We'll do it for the next problem. And then what we're going to do is tell our calculators L1 minus L2, and there's a little store button. Let's see what it looks like. I think it looks like this. On the left of our calculators. We're going to store it in L3. I don't have their calculator handy. I'm going to look at it real quick. So you guys know how to find L1 and L2. Yeah, the store button is down here right above the on. It says store. Do you see that? Where I'm pointing here? What that does, if we type L1 minus L2, store it in L3, it makes L3 the list of all your differences. It does all the subtractions for you. So if you had 2 really long lists, you don't have to stop and do each subtraction separately. You just have to type them all in, and it'll put that list in L3 for you. If you want to try that, I can pause for a minute. You guys want to try to see if you can get those numbers in L3? Let's try it, because we're going to need it for some other longer ones. So then the differences should be in L3. You can check to see if it works by going into Stat and Edit and looking at your L3, like we've done before all semester long. I'll listen to everybody click for a minute. Sounds like testing. Liam's not anybody up, his is an L3. So once you think you've done that, go to Stat and Edit and look at your L3.
Just go to one bar
It shows
stats and do
under,
it.
it shows it under. If you put in L1 minus L2 store L3,
Yeah, it shows you the differences right on your screen, but then when you go into Stat and Edit, like if you wanted to type something into L3, my point is they should already be listed there in L3. You wouldn't do one of our stats unless you actually want to calculate something. We're not quite there yet, but we might if we wanted to get the mean or something. Is that what you're asking?
How do I minus it?
Oh, so on your regular home screen, just the regular screen like where you're going to add anything, you're going to type this in. You don't even have to go into stats. So you just on your regular screen, the home screen, you're just going to type L1 minus L2. So you get a little L1 and L2 are down at the bottom there. And then you hit the store in L3. You know what I'm talking about, or do you need me to come point?
Okay.
She wants me to come point. Yeah, so now go back and get out of here, and just right here, you're gonna type L1 minus L2, right down there. And then store, And then L3.
Not even on the bed, but.
Now, so there's the list. Now if you go to stat and edit, like you were before, you should see those numbers in L3. Yours not working
Just do
either?
L1 minus L2, then hit store.
Then store and then hit L3.
After store, you then click L3, and then.
Then what?
Get it?
Hit
And
enter.
only has my shares. Yes.
And what's it supposed to do?
You could always just subtract them all on your own too. Let's make sure Kevin gets it. Anybody else having trouble getting there?
Just when it was without to.
I want you to verify that your L3 has the numbers. Good job.
She gets home, I just, so she gets told, and then she's like,
Okay,
what, you leave them.
so now we know how to do a shortcut way to get our differences. But the question is, what the heck did they tell us?
No.
So here's the important part about matched pairs. You had this list, you had this other list. Your data is really this list. This is the only data we're actually interested in. We want to know what happened to those differences. Were there positive differences? Were there negative differences? Are the differences maybe zero, which would mean no difference? Your data is actually the differences in this case. The problem won't say, hey, stop, first get your differences. You have to recognize that you have matched pairs and get this list of differences. So now let's look at the question on what it says here. Going back, so we have these numbers listed. We want to use a 0.05 significance level to test the claim that the mean change is equal to 0. Alpha equals 0.05, example 1. So the mean change. How do we write mean? Mu. So we would write mu equals 0, right? That's what the claim is. H0 or H1?
H0.
H0 because of the equal sign. But the way we make it clear that it's the mean change is we write mu with a little subscript of a D right here. And the little subscript says it's the mean difference. Because there's too many mu's you could be talking about. Are you talking about the mean for April, the mean for September? We're saying the mean difference. That's shorthand for mean difference. Let me write that up here. Mean difference. Which means all we care about is this sample right here, and is this mean? We're going to test the claim that that data has a mean of 0. What would that mean if the mean was 0? If the change in your BMI was 0, no change at all. People's weight stayed about the same during their freshman year. If it really is 0, then if it's not 0, maybe people all on average gained weight or lost weight, whatever it might be. That's what they're looking to see if there was no change. So here's what's tricky. We're in chapter 9 where everything's about 2 proportions, 2 means, 2 samples. This looked like 2 samples, but it's really only 1 sample. It's really only 1 sample, and we're testing a claim about a mean. So let's just jog our memories for a moment. Of course, we all have our packet handy because we'll reverse to it every 2 minutes. 1 sample was over here. I'm on the wrong side. Sorry, I'm backwards. Was over here in chapter 8. When we had 1 sample. So if we have 1 sample and we want to test a claim about a mean, what does this tell us to use? Either a t-test or a z-test.
One prop Z.
Well, not 1 prop, that'd be for a proportion. We're testing a claim about a mean. So go down a little bit where it says 1 mean. You see that? So if we have 1 mean, it's either a z-test or a t-test. Why would we use a z-test? What would we have to know? Yeah, we'd have to know sigma. We'd have to know the standard deviation of our differences, which we don't know. So we won't ever know that. We just found these differences. So we would have to do a t-test if we had 1 sample. Do you agree with that? So the good news is it talks about it here to remind you what to do when you have one sample, but also look at the very bottom of that middle column where it says matched pairs. When you have matched pairs, it says find your D's, which are your individual differences. That's what we just found in our list there, right? Find our differences. And it even tells you what mu D represents, the mean difference. Right? And at the very bottom, it tells you to do a t-test. But the important thing is when you have matched pairs, you really only have one sample, not two. So it's not a two-sample t-test like we were doing for homework. Okay, so let's keep going then. If we're going to do a t-test, I need the rest of my stuff going on over here. What's H1 then? Not equal to 0? And then I want to do a t-test. And guess what I'm going to tell my t-test? Data. I have the data. I don't have to tell it X bar and S and all that. We have the data. So when we go into our t-test and tell it we have the data, which list are we going to give it? L3, because that's where we put the differences.
So you just change it.
Change it to L3. And then I think the only other thing it wants is that it was a not equal to sign. Anything else it wants? No? Is that all it's asking for?
Yeah.
Everyone, you have to tell it you have the data though, so it does all those calculations for you.
Mine has like a M and an O at the top.
Oh, it wants the mu 0, it wants the claim. That part should be there, you're right. Let's squeeze it in here. It wants to know what the claim was up here, otherwise it can't do the test. I don't
And then it
know.
wants the frequency too.
Oh, right, frequency was always 1. So the mu 0, the list, the frequency is always 1. And then it wanted the not equal to. Now I have them all of them. What's mu 0?
0.
0, because that was our claim up there, right? That's still the same thing it's always been, the mu from H0.
After I put in L3, there's some flashing thing next to it.
A flashing thing next to it, I want to look at
It's like a A or
that.
something. I don't know why.
It went away, flashing.
Yeah.
Oh, you fixed it, good job. Flashing thing is no longer there. So are you now at the screen where you have your test statistic and your p-value? Heard quite a few yeses.
Yes.
Okay, so this was step 1, is to write the hypotheses. Step 2 is to tell me my test statistic, which should be a t this time. We did a t-test. What was your test statistic? 0.029. Step 3 is the p-value.
0.98.
0.98. That's a huge p-value.
You only go up two decimals?
We could do more. I really only need 2 though, because I'm comparing it to 0.05. So I could do more. Depends on what the problem asks for.
Okay.
So double jump.
So because this is greater than 0.05, Kirsty wants to fail to reject H0. So all this from here on is review, right? Fail to reject H0. Before we write our final conclusion, did your screen give you the X bar?
Yeah.
I just want to know what it was for a minute. What was X bar? Come again?
0.01.
0.01. So this sample of 5 students, some people lost weight, those are the negatives. Some people gained weight, those are the positives. But the average change for those people was 0.01. That's hardly any difference at all, right? So it makes sense that our results wouldn't tell us to reject H0 because our sample mean is so close to 0. So we don't have evidence of much of a difference. So then the final conclusion is, this one was our claim right here? I think that one was our claim, I didn't write it up there. What is our conclusion? Do we have evidence or not?
No.
No, we do not have
There's
evidence.
not sufficient evidence to reject it.
We do not have sufficient evidence. Do I use the word support or reject here?
Reject.
Why reject? She says reject. Someone else tell me why she's right if she is, or tell me why she's wrong. Silence.
Reject.
Why? Because the claim was H0, and all you can do with H0 is reject it or fail to reject it. Because the claim was H0, it's reject. Reject the claim that, what was their words, the mean change? Is equal to 0. Is there a follow-up? Let's see a follow-up and I forget to read it. Was that the whole thing? Does BMI appear to change during freshman year? Ms. Brunt's back there shaking her head saying no. No?
It's like minute.
So the sample had a minute change, but the whole population, did we find evidence to reject that it was 0? So again, because we're not rejecting that it's equal to 0, it appears that really it is 0. We can't say anything more than it appears that there's no change, because we didn't reject it. So what the follow-up would be, appears that BMI doesn't change. So all those myths about the freshman 15 are gone. When you have to make a conclusion about an H0 claim, you can't really be real strong about it. Just like if you go to court with someone who claims that they're innocent. If you don't have enough evidence to convict them, the strongest you can say is maybe they appear to be innocent. It doesn't mean they are, right? You can't say you're proving that they are, or you're supporting that they are even. You just say it kind of appears that they are because we didn't have enough evidence against them. So it appears that the change is 0, which means there would be no change. Questions? Good? Okay, what's the follow-up down there then?
Comments here,
Yeah, use the same data from above to get a 95% confidence interval for the change in BMI, and then we're going to interpret that confidence interval.
Would you just use T interval?
So we would just use t-interval for the same reasons, right? If we only had one sample, it's actually a review now of all the way back to chapter 7. If you only have one sample and you're looking for a confidence interval for a mean, we would use t-interval. So just like in chapter 9, the t-test and the t-interval are tied together. The one prop z-int is tied with the one prop z-test. So if we did t-test here, their only option here is to now go and do a t-interval. This is for 1b. Everyone clear why it's a t-interval?
Because we did a T-test.
So we did a t-test and we're talking about the mean change. So one sample for a mean was, we did z-interval and t-interval back in chapter 7, but again, we don't have information for z. So we do a t-interval with a C level of 95. Tell it you have the data again in L3. Make sure you tell it L3, don't let the default be L1. What'd you get? Anybody?
-0.9471
Negative 0.9475,
and 0.96745.
0.967, 5,
45.
4 or 5? We agree with his numbers? What goes in between there?
MD.
Mu D, the mean difference. This is your confidence interval. Do we get this one? Yes,
Where did you get your, say one more time?
the problem, it said construct the 95% confidence interval. The bottom of the page, see it? Before we answer their question, can someone try to tell me what these numbers mean to us, in your own words? I don't care about the zero, I wanna know what these numbers mean. Kristen
That
wants to
means
try.
that the difference in means is between the negative 0.9475 and the 96745.
Okay, so the mean difference is somewhere between here and here. Let's try to throw the words BMI in there. What does this have to do with students' BMIs? On average, what happens to the students' BMI over the course of their freshman year?
Didn't change much.
Didn't change much? It could change based on this, but then it might not. But it could change by going down by almost 1. I don't know what BMI is measured in. I don't know what the units are there. But their BMI could go down by almost 1, or it could go up by almost 1, right? Because we have a negative and a positive. So a student's BMI might go down by 1, might go up by 1, or there's the follow-up question in the notes there. It asks if 0 is in this interval. Is 0 in here?
Yes.
What does that mean to us?
Means it could be equal.
Means it could be equal to 0, which
It
means
could be no change.
there'd be no change. Because 0, if I could spell, because 0 is in the interval, mu d equals 0 is a possibility. So there's no evidence of a change. Just like we were doing with the ones last time. Let me make sure I actually answered their questions, so I walk away. What does it suggest about BMI during freshman year? I think I answered that. No evidence of a change in BMI. Anyone have a question about the 0 in the interval part? We did it in 9-1, we did it in 9-2, it's back in 9-3. This seems to be the part that confuses people the most out of all of chapter 8 and 9. And I don't know why yet, I've been doing this for I don't know how many years, but I know it confuses people the most.
What's your question?
If there's a question about what 0 in the interval really tells us. A lot of people know I'm supposed to look for 0, but they don't understand what that tells us, and so if there's anyone who wanted to clarify what it means for 0 to be in the interval or not be in the interval. You guys are all extra quiet today, so maybe you have a question and can't spit it out, I don't know. Okay, that one? Is your hand up, Christy?
Yeah.
Were you just thinking?
So I was reading example 2, is H1 always going to be M with the subscript D equals and not equals?
She's already working ahead. So her question is the claim, if you're gonna do a test, always gonna have a 0 in it? And the answer for most of our cases is yes. But I could have asked the question, test the claim that the mean BMI increased by 1. If it increased by 1, that means it's greater than 1, or it went up by more than 1. So it could be that I'm asking for a specific amount of a change, but most of the time we're just asking, is there a change or not? And if there's no change, then it's 0. So it's not always, but most of the time the answer is yes. You see how the subtle wording could be something slightly different? Like, for example, if I gave you the chapter 8 and 9 test back in August and I give it to you again next week, I could test the claim that on average you guys all improved your scores by more than 50 points. I think that's totally reasonable, because you probably would have gotten a 0, and now you're going to at least get 50. So I could ask for something other than 0, but most of the time it will be 0, because 0 represents no change. So she's working ahead, so let's go on to example 2. Now we have researchers collecting data on the number of hospital admissions resulting from motor vehicle crashes. And they have results for Fridays on the 6th of the month and Fridays on the following 13th of the same month. And we want to test the claim that when the 13th is on a Friday, the number of hospital admissions from crashes are not affected. So somebody thinks that the Friday the 13th might make it more likely that people end up in the hospital. It's Friday the 13th, it's unlucky. I mean, that's what they're worried about here. The claim, though, doesn't say anything about the mean. It's implied in there. What's the claim in the words they have here? What's the claim?
That mu equals 0.
Well, it doesn't say that. What's it say?
When the
That
13th
one.
day of the month falls on Friday, the numbers of the hospital admissions from motor vehicle crashes are not affected.
The number of hospital admissions are not affected. What does that mean if they're not affected from the 6th to the 13th?
You'll see it's 0.
There's no change, she's telling me over here. So they're really saying if it's not affected, there's no change? So if there's no change, that's why Hector's totally right. It is mu equals 0. So let's write down the claims and then we'll go back and talk some more about what to do. Mu d equals 0 means no change, which is the same as saying it was not affected, right? There wouldn't have been any difference. No change, no difference. Which is why Kirsty was asking, are the claims always the same? Most often, yes, but not always. So what do I need to do this problem? The differences. She's over here telling me the differences. How do I know these are matched pairs? You can't just tell me it's because it's in this section and every problem in here is matched pairs, because it's not going to be the way it works next week. When you read this problem, what part of the way it's presented to you tells you that it's matched pairs?
I see them as columns, like
Yes.
separate columns.
Okay, so she sees them as separate columns. Yeah, Hector?
It's asking us to find the difference between two different sets of data.
So that's not enough, actually, the differences between two types of data, because I could have said, do men and women go to the hospital more or less, right? And then my sample of men would have had some numbers and a sample of women, and those would have been two different samples. So comparing two lists is what I was warning you guys about earlier. You have to figure out what makes them matched up. Yes?
This is like of the same month, is that?
Yeah, on the same month with the 7th and then the 13th right afterwards. And it also, I will argue, is a little bit vague in this problem. And that they should have told us that it was 5 different hospitals, or 6 different hospitals, or maybe 6 different times at the same hospital. They didn't really spell it out, that those are, I see them maybe as 5 different hospitals. The first column is hospital number, 6. Hospital number 1, hospital number 2, similar to the way I had them numbered across the top here. When I give you a problem on the exam, I will make sure it's very clear that they're matched up, because I think this one was actually a little bit vague. Because if they were different hospitals, then there would be no way to even compare them. Because one hospital might always have more people than the other one, regardless of the day. Yes, ma'am?
So what would be like keywords that it's
What would be the keywords? So a lot of the times it's the before and after, like the problem we just did. There'll be problems where they have like married couples, siblings, the left and right arms of the same person. There's a problem coming up either in the lab or today of that. There'll be something that tells you that they really only had one sample and they got 2 numbers from each. So that's why I'm saying this one's actually a little bit vague, and it doesn't really say there's 6 different hospitals, but it does tell you that the 9th and the 13th came from the 6th and the 13th came from the same month. Like those were right after each other, So it tells you that those were right connected to each other. So that's probably the only key word in here where it says Friday the 6th and Friday the 13th of the same month. So that tells you those are matched up together. You guys are all going, okay, Jill, you're going on and on about this, but I'm warning you, next week, when they're mixed in with everything else, you need to be able to tell if they're matched pairs or just two separate lists, because if they were two independent lists, we would do a two-SAMP t-test and a completely different way to write our claims and everything else. So you need to spend time deciding if you have matched pairs or not.
Because on an exam, they're gonna be mixed.
Yeah, they're all mixed up, so you need to decide how it's matched pairs, so the keyword question is really good.
Yeah.
Okay, so we need to find the differences. Find the differences. So what's the easiest way to get those? Put them in lists and store them in L3. So you could type them in L1, you have to type them in there, and L2, and then store it in L3 again. Some of you were already doing that while I was yapping. I'm going to write the list up here while you're doing that. See if I can subtract in my head. Do you agree with my numbers? I subtracted in my head, so don't trust me. Yeah, Kai says yes. So now that I have my differences, what do I need to do?
Test.
T-test, yes. I need to do a t-test. I'm going to tell it that mu0 equals 0 in this case. We're going to tell it to go look at our list, which is L3. And we're going to tell it we have a not equal to claim. And we should get a test statistic of
Negative 2.7.
7, say here the last digit,
1.
7.1. Agree with that? And a p-value of
0.042.
0.42. Again, I always forget my significance level. What was it for this problem?
0.05.
0.05. So what does that tell us? What do we do?
Reset.
We're going to reject H0, Christian says, because my p-value is smaller than my alpha. So step 4, bless you, I'm going to reject H0. That p-value method is every day, all day, if you haven't noticed. So this was my claim that the hospital admissions were not affected by Friday the 13th. What's the conclusion? The silence is deafening today, guys.
What was the question?
I didn't ask for the conclusion. Hector
There is
wants to try.
sufficient evidence to reject the claim that the 13th falling on Friday has no effect on hospital admissions from motor vehicle crashes.
Beautiful. There is sufficient evidence, because we rejected, to reject the claim, because we rejected our claim, which was H0. And then it's the whole claim, which is pretty long. You said it, I can't remember it off the top of my head. When the 13th falls on a Friday. Well, by the way, with the quizzes I passed back to you a little while ago, some of you didn't write out the whole claim, and I gave you one free pass, and that was it. But I wrote on there, because you said, there is sufficient evidence to reject the claim, and you stop there, and then I wrote, and you should restate it right here. If you don't on the exam, you're going to lose points. You get one free pass, and that's it. On Friday the 13th, I just lost my place. The number, you want to assume that someone who knows nothing about statistics can read your conclusion and make sense of it. Number of hospital admissions are not affected. I think I left out a few words, but it's pretty close. In your own words, what does that tell you? In your own words. You had to go tell somebody what you just found out.
Friday the 13th doesn't matter, right?
Doesn't matter? Does matter?
No,
Uh-oh.
because it doesn't equal 0, it means
Mm.
that there was a change.
You see that, Kevin? We rejected that it equals 0. If you're rejecting that it equals 0, if you reject this, that means there is some difference. See that? There is some difference. We rejected that there was no change. So double negative makes it hard to interpret. It appears that there seems to be, so it does affect it. Now, some people could argue it's because of bad luck. Some people could say that maybe people take more chances because it's Friday the 13th. I mean, we don't know why, but the evidence shows that there is a difference from the 7th of the month to the 13th of the month for whatever reason. That's not our job to figure out the why. Everyone see that it shows there is a difference? Okay, let's do the follow-up interval, then we'll take our break. The follow-up says, use the same data above to get a 95% confidence interval for the change in hospital admissions. What am I going to do for 2B? T interval? T interval? It doesn't want to erase. T interval with the data using a C level of 95. You got it already, Samantha? Did you? What you got?
Negative 6.493. And then, negative, 0.173.
I'll round it to 2 decimal places. Yeah, yeah. We agree with her numbers?
Mhm.
Those are negative values in that confidence interval. That 4 looks really weird. I have to change it because I don't know what it looks like. It doesn't look like a 4 to me. What does that mean? What does this confidence interval tell us?
It doesn't contain a 0.
It doesn't contain 0. 0's not in there. Agree with that? 0's not between these two negative numbers. 0's not in the interval. So what? So 0's not in there.
So you can,
He's trying. He can't handle the silence anymore. Who wants to try? He gave up already. Nice try though, Anthony. What does it mean that 0's not in there?
So you can reject HO?
Okay, but we didn't write a claim that because we just got the confidence interval. Hector wants to try?
The mean difference cannot equal 0.
The mean difference in hospital admissions is not 0.
There has to be a difference.
So there's some difference. We don't know how much of a difference. There is a difference between the 6th and the 13th of each month. How much of a difference?
Somewhere in there.
Somewhere between less than one person, all the way up to maybe 6.5 people on average, more. Yes,
So since they're all negative, doesn't that mean that the admissions on the 13th are greater?
Yes, so she wants to say, because they're all negative, remember we subtracted, I don't have the list here, we took the 6th minus the 13th, and we put them into our list. The 6th is the smaller number because these answers came out negative. The 6th minus the 13th, so the 6th was definitely lower than the 13th. So I would actually put that up there, or you could even turn it around where she says the 13th is bigger. I could say the 6th is lower. Admissions on the 6th are on average up to 6.5 less people. Than the 13th. I didn't really include the lower number because it's so close to 0, so it's up to 6.5 more. Less because my interval was negative. So the first list must have been smaller than the second list. On average, by slightly more than 0 up to 6.5. A lot of you like to just check out during this part. You're like, I got my interval, I'm good. But interpreting it is important, and that's the whole reason we do statistics, so we can interpret our results. Crunching the numbers and not knowing what they mean to tell you anything. It'd be like if I said, hey, I did this really cool math problem, and my answer was 7. Isn't that amazing? And then you might say, well, what were you trying to figure out, Jill? Oh, well, it was that somebody won the lottery 7 times. Well, that is amazing now that I told you what it means. But if it's, that somebody has 7 cents to go shopping, that's not so amazing. I guess it's amazingly bad, but but if you don't know what it represents, getting the answer means nothing. Questions there? Okay, let's go take a 10-minute break. See if we can come back slightly more awake. Maybe you all need a little caffeine, sugar, both. We'll come back in 10 minutes and we'll do the last problem here and move on to 9.4. What I would like you to do, Nick showed me a really cool trick that I never knew on how to get everything into list 3 even easier. So we're about to do that last example on page 135. Type those 2 lists in, but don't do the list 3 thing yet. Just put them in your lists. And then I'll show you Nick's cool trick. Give all the credit, I don't know where it came from before that. So here's my calculator with the 2 lists typed in there. Just turn the light off for a minute while I show you, then I'll turn it back on. That way they can see it better. So I have the 2 lists up there. You guys type it in. Can you see your calculator now? Or you need the light back on? I didn't realize I turned the light off.
see it.
Do what I ask in the dark. Is that enough? Probably not.
Yeah, it is.
Is it? Okay, good. Thank you, Christy. I want to wait till you guys all have your list typed in there. Okay, so we have them in? Maybe? Is there anyone still typing? I can't see you now, it's all dark. Okay, so we have the 2 lists in there. We want to put it into list 3. Here's the really cool thing he just taught me. List 3 is empty right now. Go up to the top of L3 where it's highlighted right here at the top. So it's dark up there. And then all you have to do is type in right here, L1 minus L2. So I made sure I was up here where it was dark up here, highlighted up here. And then right here I typed in L1 minus L2. You see that? Then when you hit enter,
Need to put comma or anything in there? Or?
nope. You just hit enter and it magically puts it in there.
No one L2?
L1 minus L2.
Or minus?
Because remember that's what we're trying to do is put the differences in L3.
Although mine added them, right?
Yeah, you can't add them, you gotta subtract them.
So clear.
So the important part is you have to be up here. All the way up here at the top. And then you can type it in right up from there, L1
Sweet.
minus L2. Now we don't have to exit out and go back in, it's just automatically right there. Thanks, Nick. Okay. So now let's talk about why this is a matched pairs problem now. Just because we did it doesn't mean it wasn't a matched pairs. So what are the key words in this problem that make it matched pairs?
Which one?
What are the key words in this problem, example 3, the ones we just put in our calculator, that make it a matched pairs problem?
Before and after.
Yeah, there's a before and after they talk about. They said students were given a pre-test and a post-test. Right, so that pretty much tells you each student has a before and after score. So you have 1, 2, 3, 4, 5, 6, 7, 8, looks like 9 students who took a pre-test and a post-test. And we're trying to see if their scores improved or maybe got worse, depending. And so this problem just says to construct a 90% confidence interval for the mean difference between the post-test and the pre-test. Now be careful. Look at what it asks you to find. The difference between the post-test and the pre-test. Which one came first there?
Post.
Uh-oh.
Oh, I mean pre.
No, look at it again. It says post and then pre. That's not what we did. It wants the difference between post-test and pre-test. Important that they ask for it in that order.
So we did L1,
Yeah, we did L1 minus L2, which we did pre-test minus post-test. Cecilia caught that. Post-test is what we put into L2, right?
Yeah.
And pre-test is what we put into L1. So if the problem is asking for a difference between the post and the pre, guess what I really need to put into L3?
L2 minus L1.
L2 minus L1. It mattered in this case. Just like if I asked you to find the difference between my age and Jenna's age, you would do mine first and then hers. Where if I said the difference between hers and mine, the order matters with subtraction. So we have to go back and fix it and put L2 minus L1 into L3. Because of the way the question was asked.
So L2.
L2 minus L1. So make sure you read which difference they're asking for.
So the last part of the.
Right, and usually they do ask for them in the same order that they give them to you, but not always.
What would be the function?
The function.
Like, greater than or less than?
Well, they didn't ask for a test. It asked for a confidence interval. A 90% confidence interval. So we're just gonna do a T interval. Cecilia's all over it. She finally woke up. Hooray. She's the only one awake. I got somebody awake, thank you. T interval, why is it a T interval?
Because you need teachers.
We would have done a T test, and we really only have one sample. So we're gonna do a T interval. We should have now your new L3. And we're gonna tell it that we have a C level of 90. I'd like to read the problem. Wait, 90? Anybody have a question as to what we're doing? And I'll have to show you while I wait for you to push buttons. What do we get?
Negative 1.167.
1.167,
And a 12.056.
we agree with Kevin's numbers?
Yes.
So there's my 90% confidence interval for the difference between the post-test and the pre-test.
Could be 0.
Hector's over here saying it could be 0. Why could it be 0?
Zeros in the middle.
Zero's in between there. So if it could be 0, does the course appear to significantly improve the students' understandings?
No difference.
Nope, there's no evidence of a difference. I love it, you guys are finally getting it. No evidence of a difference. Now someone argue that, look, it could improve your score by as much as 12 points. The difference could be as much as 12 points higher.
Zero too.
Could be 0, or your score could go down. Right, the difference might even be negative, that would be bad. You want to pay all this money and do a special course and have your average go down? I don't think so. So the only way this would be a good scenario is if these differences were all positive. That means they would be improving the scores by a certain number of points. Like if it was positive 1, we say it improves it from 1 to 12 points higher. You all right with that? Okay, let's look at our packet for a minute before we go on to the next section. I want to point out a couple things. On page 1. Page 1 of the packet. Over here on the right, where they're talking about confidence intervals for 2 samples. This is what we've been doing in chapter 9. We did the 2 prop z ints back when we had 2 proportions. We did the 2 sample t int when we had 2 means. And then down there at the bottom it even tells you, hey, if you have matched pairs, it's really only 1 sample. Take your differences and do the t interval. So you don't necessarily have to remember to go back and look at the 1 sample later. So the matched pairs is down there as well.
Interval or t-test.
Yeah, so t-test is they're asking you to test a claim, that's actually on the second page. But
Okay.
t-interval if they're asking for a confidence interval. So this lower
Oh,
right-hand
it just
corner
says confidence
is just for
intervals.
intervals.
Oh, yeah.
But I would argue, like you were kind of just pointing out, that you don't really need 2 separate pages because t-interval goes with t-test and 2-samp t-test goes with 2-samp t-int and so on. But the matched pair shows up there for intervals. And then on page 2, make sure I'm looking in the right place, we've done everything in the middle column now. Everything in the middle column. We did 2 proportions, 2 prop z tests, now we're talking about tests. We did 2 means last time, 2-samp t test. And then down there at the bottom, we have the matched pairs, which is where we did the t-test. You want to make sure that you know how to find things on here and which part's important, which part you can ignore, what points you in the right direction. So all the tests in chapter 9 are in the middle here. The confidence intervals are back on that first page. Now there's only one more section in chapter 9, which is up here in the upper, upper right. It's my left hand, very confusing. The upper right.
Which one?